Okay, in this video we're going to get started looking at our template that we're going to use to look at data structure stuff. So the directory for this is inside the class and then ds for data structures, and we'll take a look at these files here. First of all, we'll see what it does. So the program is already compiled, and if I give it a command line argument, that's a file name, it looks and takes every word that's in the file and has a count of how many times it appeared. This means that in the file words.c, W appears as a word 19 times. As a larger test, I will often do Shakespeare. I have the Project Gutenberg text file with the collected works of Shakespeare in that directory. This takes a few seconds to run. And there it is. And these are in, they're not particularly in any sorted order. Alright, now we want to look at the files that we have here. There are two C files, one .h file, and one Makefile. And I'll show you these and then make some notes on how things are organized. So this is often how, well, we'll already start taking some notes over here. And we'll put this into our ISU CS core information about how the files are organized. Okay, so this is under the category of organizing a project. So the Makefile contains the commands to compile the project. Star.c files have C code. Star.h files have function prototypes and type definitions. Go ahead and look at the H file we have here. Okay, so this is a data type here that I'm going to use to keep track of words and word counts. There's a character pointer. There is an L that I use to keep the length of the string in the character pointer. And there's a count that I use to keep a count of how many times that word appeared. So this struct word t, struct word t here, that defines a structure, and I could use it like this. So I could declare a variable something like that. That's a struct word t. What the type def does is it gives me a new type that has this as what I need to type, and it actually does this. Okay, so it does the structure and I don't have to type the struct all the time, and you can see that in the function prototypes here. Okay, these are prototypes. It's just the return type, the parameters of the function with a semicolon. So the actual code for the functions is in the .c file. So this is C code, including code for functions declared in star.h. This, okay, so that's the H file, and then we have two .c files. So one of the .c files just has the functions from the words.h. So all the functions that are given prototypes in words.h, I have them defined in here. Note that this has to match exactly. When I compile it, if there's something different here, then it will have a problem. So if we look at words.h, so here's words.c up here on the top, and then here's words.h down on the bottom. If I have a mismatch between what I declared and then what I define, then when it goes to match these up, there will be a problem. So it should be the same. Alright, so there's the .c and .h, and I'll say that together, let's see, so a library, we have star.h file, potentially more than one, defining the functions and types used, and then star.c to go along with star.h with the actual code. This is typically the way it's done, and the reason is you can look at this .h file and see everything that you have available to you. If you're going to use this package, then this .h file really has enough to know what's going on. And then any other file that wants to use any of these functions, you just need to #include words.h. I have here simple.c. Simple.c has a main, and I want to use the functions from the words.h, so I #include the words.h. Alright, that's our organization there. Now for compiling, we can compile this by saying words.c, simple.c, they both have C code that we're going to need, so I can just put them together like that, and one of them needs to have main. This one here just has the functions that are declared in my words.h. This one here has the main. So we make a note of that. Note that only one star.c should have a main function. So I could compile that way. I have a Makefile here that looks like this, and so this is a script file. Compiler is a variable, so when it comes down to this line here and it does $, is for expanding something inside, so it expands this variable. When it comes down here, it'll actually put GCC there, and my C flags is another variable. This is for the debugger. GNU debugger puts debug information in there. Pedantic is enforcing some rules to make sure we enforce all the rules, and then warning all. And here we have, this will be GCC, some flags, words.c, simple.c -o. This here is a name that's a label for the rule. So if I say make simple, that's what it does. Alright. So for now, we'll just use it like this and not go into all the different rules that you can put into a Makefile. This makes it convenient that we don't have to be typing GCC all the time. And if we just do make, there's only one rule in there, it'll just do that rule. Alright, and so make is a command that's on the system. It looks for a file called Makefile in the current directory. Alright, that's the organization of our code. I'll also mention this #if ndef #define. This business here is called a pound if guard. Okay, so what this does is if words.h is included from multiple different files, so for example, words.c includes words.h and simple.c includes words.h, what the compiler will do is it will basically copy and paste that file into the current program. So it's like everything in words.h actually appeared here. And that would be a problem if I'm in words.c. So here's words.c. I include words.h, so I see, aha, there's a data type called word_t. Next it goes to compile simple.c. It says, aha, I pound include this, there's something called word_t. But now the second time that it's looking through the words.h, there already is something called word_t from the first time we saw it, and that would be a problem. So this pound if guard is to deal with if we pound include words.h from multiple different files. Without pound if guard, compiler may have a problem with seeing these declarations twice, because you're not supposed to repeat a declaration. If we are in simple.c, I should not do int x and then later on in the program int x. That's not allowed like this. So if I did it like this, that's not allowed. And the same way with declaring these data types and functions, I should not see this a second time. So what we do is the first time it comes through, this words underscore h underscore, that's just something that I chose. So that won't be defined. It'll go ahead and define it. So first time through it's not defined, we go ahead and define it. We declare the type and these function prototypes and then end. Second time the words.h is included. This is already defined, so the rest of this is skipped. This makes us skip past the declarations the second time words.h is included. So this also is something that you'll tend to have in your source files for libraries. Okay, so those are common things that we'll have when we have some sort of a package. We have a .h file, we have a .c file, they go together. There's a Makefile, and there's something that has the main program. I think we'll call that it for this video. This was just introduction to organizing a project, and then next up will be actually looking at this code.